often, so long as we bear that in mind, we can still use the normal distribution. Okay, so let's do this one here about filling paint cans. So same sort of idea as the flour. We've got a machine that's putting the paint into the can. This is a lot more valuable than flour, so probably they're more accurate. A machine fills paint cans to a mean volume of 10.1 litres with a standard deviation of 0.15 litres. The cans are supposed to have 10 litres in them. What percentage are underfilled? Okay, so we've got a picture here of the normal distribution with a mean of 10 and a standard deviation of 0.15. And our value of interest here is 10 litres. So we want to know how many of them are going to be under 10 litres. So what we need to do is find the area less than 10. So this amount here, and this shaded value here will tell us what is the probability of any particular can taken at random having less than 10 litres of paint in it. Okay, so we don't want to do this by hand because it's pain. And I haven't bothered with the whole spreadsheet as a calculator thing here, but you know how to do it by now, surely. So this is back in the days where I decided we should put everything like this. So we've got our mean, our standard deviation, our lower and our upper bound. So, or you can just put your things in here. So just like yesterday when we talked about the binomial and the Poisson distributions, you just go equals norm dist, open your brackets, and it tells you what it wants. So x is the value we're interested in. So in this case it's 10. You can see it's come up as 10 over here. The mean is 10.1. The standard deviation is 0.15. Now, here's a nice thing for this one. It's always true. Okay, this one here, always true. For any problems that I will give you, this will always be true. Now, this is because in a continuous distribution, the probability of an exact amount is 0. So, because you're meant to be looking for areas. Now, if we come back a minute, if I say, what is the probability that is there exactly 10 litres of paint in a paint tin, that is actually 0, because if you take them to an infinite extreme, we've always got our measurement error in there. So it's just sort of one of the oddities of the normal distribution, which actually makes it quite a lot easier than the other distributions, is that you don't need to worry about whether it's less than or equal to or just less than. So that the probability of being exact is actually 0. So we just put in these numbers, and the answer is 0.252. So that means that 25.2% of cans will be underfilled. Okay, and I've just got down here, in all examples, it will always be true for cumulative.